In this lesson, we're going to look at quadratic equations that have radical roots. We'll first review radicals. We're going to review the discriminant and use it to identify radical roots, and then we're going to apply the quadratic formula. So a radical is an expression that is bound by the root sign. So for example, you have the cube root of x. So a radical consists of three parts. X is called the radicand, that is the number under the root sign. 3 is the degree, so it's going to be a cube. And then the square root sign is called the radical. Now we're going to use the discriminant, which is the b squared minus 4ac portion of the quadratic formula. And how do we know if this quadratic equation is going to have a radical root? We're going to apply the discriminant, which is b squared minus 4ac. It has to be greater than 0, and the value of b squared minus 4ac must not be a perfect square. If it's a perfect square, it's not a radical root. Now, we're going to see how to put this to practice. So what type of roots will this equation have? The first thing we're going to do is find the values of a, b, and c. So a is equal to 1, b is equal to 6, and c is equal to 6. So b squared minus 4ac equal to 6 squared minus 4 times 1 times 6, which is 36 minus 24, which is 12. Because 12 is not a perfect square, and by that we mean there has to be a number that multiplies, that a perfect square would be a whole number that multiplies by itself to give you the specific number. In this case, we have 12, which we cannot find a number that is multiplied by itself to give you 12. Therefore, 12 not being a perfect square becomes it's going to give you radical roots for this quadratic equation. Now, how do we use the quadratic formula? The first thing we do is we compare the quadratic equation with ax squared plus bx plus c equal to 0. And then we substitute the values of a, b, and c into the quadratic formula, and we solve for x. Let's get started. So we have ax squared plus bx plus c equal to 0. So we have a equal to 1, b equal to 6, and c equal to 6. So therefore, we know that x equal to minus b plus or minus square root of b squared minus 4ac over 2a. And now we're going to substitute. X is going to be equal to minus 6 plus or minus square root of 6 squared minus 4 times 1 times 6 over 2, which is going to give us negative 6 plus or minus square root of 36 minus 24 over 2, which is negative 6 plus or minus square root of 12 over 2. So let's decompose 12. We have 2 and 6, 2 and 3. We can see this is a pair, so we have a perfect square right about here, and we have a radical right at 3. So let's bring this up here. So this is going to give us negative 6 plus or minus 2 square root of 3 over 2. So we have even numbers all over the place. So negative 6 divided by 2 is negative 3. 2 square root of 3 divided by 2 is going to give us square root of 3. So x is equal to negative 3 plus square root of 3 and x is also equal to negative 3 minus square root. Now, let's compare. So, a equal to 1, b equal to negative 10, c equal to 12. And that's because we're comparing against ax squared plus bx plus c equal to 0. So let's get the quadratic formula. It's going to be minus b plus or minus square root of b squared minus 4ac divided by 2a. Now it's time to substitute. So x is equal to negative of minus 10 plus or minus square root of negative 10 squared minus 4 times 1 times 12 divided by 2 times 1. So this is going to give us 10 positive, negative becomes positive, plus or minus square root of 100 minus 48 divided by 2, which is 10 plus or minus square root of 52 divided by 2. So let's decompose 52. We have 2 and 26, and then 26 we have 2 and 13. So we got a pair here, so that's going to be perfect square over there, and 13 is going to represent a radical. Let's bring this up here. This is going to be equal to 10 plus or minus 2 square root of 13 divided by 2. We can divide each of the terms by 2, so we have 5 plus or minus square root of 13. So x is equal to 5 plus square root of 13, or 5 minus square root of 13. These are the roots of the quadratic equation. Now we start off with our ax squared plus bx plus c equal to 0. So when we compare, a equal to 2, b equal to negative 12, and c is equal to 13. But we know that x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So we're going to substitute now. So x is equal to negative of negative 12 plus or minus square root of negative 12 squared minus 4 times 2 times 13 divided by 2 times 2. So this is going to give us 12 plus or minus square root of 144 minus 104 divided by 4. So this is going to give us 12 plus or minus square root of 40 divided by 4. So let's decompose 40. We divide by 2, we get 20. We divide 20 by 2, we get 10. We divide 10 by 2, we get 5. So we have a pair here, which is 2, and then we have 10 here. So let's bring this way up here. So this is going to be equal to 12 plus or minus 2 square root of 10 over 4. So what we're going to do is the greatest common factor here is going to be 2. A number that can divide all of these terms together is going to be 2. So 12 divided by 2, we have 6 plus or minus square root of 10 divided by 2. So therefore, x is equal to 6 plus square root of 10 divided by 2, it's also equal to 6 minus square root of 10 divided by 2. And finally, apply the same method here. Ax squared plus bx plus c equal to 0. So a equal to 3, b equal to negative 16, c equal to 19. We know that x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So when we substitute, we have negative of negative 16 plus or minus square root of negative 16 squared minus 4 times 3 times 19 divided by 2 times 3. When we simplify, we have 16 plus or minus square root of 256 minus 4 times 3, that's 12. 12 times 19, let's do that quickly here. 12 times 19 is going to be 228 divided by 6, which is going to give us 16 plus or minus square root of 28 divided by 6. Let's decompose 28. You divide that by 2, you get 14. You divide that by 2, you get 7. So you get a perfect square with 2, and then you have a radical with 7. So let's bring this guy up here. So this is going to be equal to 16 plus or minus 2 square root of 7 divided by 6. The greatest common factor of all the terms, the whole number terms there, would be 2. So we divide each term by 2. So we have 8 plus or minus square root of 7 divided by 3. So x is going to be 8 plus square root of 7 over 3, or 8 minus square root of 7 over 3. So this is how you can apply the quadratic formula to solve quadratic equations that potentially have radical roots.